Hi, we're going to learn about the law of cosines today. So the law of cosines is like the law of sines. It's used for oblique triangles, triangles that are not right triangles, those non-rights that maybe they have 3 acute angles or 2 acute and 1 obtuse angle. So here we have triangle ABC below, and we're going to kind of dissect it, break it apart, and see how the law of cosines works. So the first step I did was drew this perpendicular line that goes from the vertex C down to my base. The base of the triangle, I labeled it C. So however many units C is, that goes from A all the way to B. Now the perpendicular line kind of cuts it into 2 portions. So the red line on the left represents the length x. And then whatever's left over, well, that's C minus whatever x is. So that's that portion over there. Okay, so now we want to take our knowledge about trig ratios and see if we can use those in order to express x a little bit more clearly. So we say, well, x, it's right next door to angle A, right? So it's adjacent. So why don't we just set up a trig ratio of adjacent over hypotenuse, x over b? Well, we know that adjacent over hypotenuse is cosine. So we have x over b equals cosine of a. And once we solve, we can multiply both sides by b and find out that x is really equal to b times cosine of angle A. Alright, that's our first step. Second step, we're going to do, something kind of similar, but we're taking a look at the other side of the triangle. So here we have, oh no, we're going to look at the same side of the triangle, sorry. Step 2. So we're going to look at the Pythagorean theorem now. So first we used a trig ratio looking at x, and now we can look at x, y, and b and their relationship using the Pythagorean theorem. Because this line that we drew in here, y, is a perpendicular, so it has a right angle that we can utilize. So here it's x and y. Those are our legs, so we can do x squared plus y squared equals b squared. So that's step 2. So short and simple there. Step 3 is where it gets a little bit more lengthy, but we can still do it step by step and figure it out. So we're looking at the right triangle that's on the right side. So looking right here. Going down. Let's take a look at the whole thing here. I'll outline it. And over. And then from our vertex C down to B. So this is the triangle we're kind of focused on right now. Alright, and the way we're going to look at it is using the Pythagorean theorem because of that right angle there. So we can take our legs, well, y is a leg, and c minus x is a leg, and use them in connection with our hypotenuse a. So we do y squared plus the quantity c minus x squared will equal a squared. Okay. Now we have to look at this quantity and kind of FOIL it out. So look off to the right here where we expand it and we did c minus x times c minus x. So when you FOIL that out, we get c squared minus 2cx plus x squared. Okay. So we had to get rid of those parentheses by FOILing it out. And then the next line down shows how we've broken it apart. Alright, so we're right here now. Alright, so we have y squared plus c squared minus 2cx plus x squared equals a squared. Okay, the next step is just taking and rearranging things. All of these terms are just being added or subtracted together, and so we can add in whatever order we want. It's the commutative property of addition. So I wanted to put my x squared over here by my y squared so it's more alphabetical. So I moved it over, so now I have x squared plus y squared. And then when you look at that, those 2 terms together, look up here at number 2. Those together represent b squared. We solved that part earlier. So we can substitute b squared in place of x squared plus y squared to simplify our expression. So that's going to help us out. So we bring down everything else, And then there's something else that we can substitute. Notice the x right here. Where did we see what x equaled earlier? Yeah, look up at number 1. X equals b times cosine of a. So just like we substituted in earlier, we can substitute this in for x. So that gives us b squared plus c squared minus 2c times b times cosine of a. Just substituting that portion in. Alright. Pause if you need to. Looking back, making those connections. Because now we're ready to look at the law of cosines. So everything's been rearranged. And so it tells us that a squared is equal to b squared plus c squared minus 2bc cosine a. All of this is being multiplied. Now, similar reasoning, if we just look at this triangle at another angle, would give us the same kind of situation for b squared. So we have the same formula, only the letters are manipulated slightly differently. Look here, if we're starting with b squared, then the angle that we're describing is the angle b. And on our final equation, we start with c squared, and so the angle that we end with is the angle c. This one in particular is a nice one. C squared equals a squared plus b squared minus 2ab cosine c. What does this part look like? Right here. Pythagorean theorem, right? Exactly, and that's what we were talking about at the beginning, is that non-right triangles, well, they still have some very similar relationships to right triangles. So the law of cosines is a modified version of the Pythagorean theorem, just made to work for those non-right triangles. And now we have information that we can use in these formulas in order to solve for a missing side length. So down below is an example, and here I wrote SAS, so side, angle, side. So if you're looking at triangle ABC, we know what two of the sides are, and then the angle that's right in between them, that is 37 degrees. That's the one we know. So we label it side, angle, side because we go around the triangle as we say what we know. So we know one side, and then one angle, and then another side. Okay. So here, which side is across from 37 degrees? Yep, side C. It's directly opposite of 37 degrees. So that means that we can use the form of our law of cosines that starts with c squared. So we always write out the formula first, and then we plug in the values that we know. We know that A is 8, B is 11, so those get plugged in everywhere where we see an A or a B. We also know the measure of angle C, so we plug that in for cosine of 37 degrees. Next, we're going to simplify. We square the 8, square the 11, find their sum, 185. Negative 2 times 8 times 11, all of that together gives us minus 176. Be careful right here, do not subtract the 176 from the 185. Because of order of operations, you can see that this is being multiplied by the cosine of 37 degrees. So that takes precedence over the subtraction. So always remember your order of operations. What we can do, though, in order to keep our answer very accurate, is punch everything into the calculator at once. So if we know that c squared equals all that, why don't we just square root it and solve it all in one go? Okay? So in the calculator, we're going to put in second square root 185 minus 176 times cosine of 37 degrees. Close your parentheses. And we get that C is about 6.666 units long, and that's rounded off to the nearest thousandth. Alright, so that is how we use the law of cosines. And there are our notes for the day. We'll be adding to that in our next podcast. Thank you.